Welcome to e-Pathshala lecture series in computer science, and this is a course in cloud computing. Today we are going to talk about cloud networking. Now, cloud networking, if we look at the overview of what is how networking is related to cloud, we see that there are various reasons of doing cloud networking. So, the networking basics are what we have to study. We have to look at the virtualized components of network, then we see that network virtualization, how it works, and network function virtualization, and then software defined networks, and there are software protocols and standards, and network as a service. So, today we will look at the first three points of networking. So, these are our learning objectives. We will look at the networking basics, and then we will see the virtualized networked components, and then overall network virtualization, followed by summary. So, these are the network components. We have the hardware components, software components, and hybrid components. In hardware components, we have switches, and we have routers, and we have load balancers. All these components can be implemented in software. So, in software also we have switches, routers, and load balancers, and when we have some part of hardware and some part of software combined, we have hybrid networking components, and VPN and VLAN, as we are going to talk about today, are part of the hybrid mechanism. So, let us quickly look at what is networks and how it is beneficial. It is connecting computers. So, we have various types of implementation for networking. We have a local area network or LAN, WAN, metropolitan area network or MAN, campus wide network, and home area network. These are depending on the area using which we implement the network can be categorized into these types. What is the significance why we are concerned about networking so much is because without the network computers are not useful at all. If we take an example of a mobile, if we do not have the connectivity and we do not have Wi-Fi, we do not have the SIM card, and we do not have the Bluetooth, then with all its power this particular machine becomes quite useless. The usefulness of a mobile device is to be able to connect through networking to the outside world, to other mobile phones or other devices. So, the typical ISO-SI layer of networking has 7 layers, and these are the 7 layers. When we talk about cloud networking, or when we talk about virtualizing a network component, all the 7 layers get affected. So, we have to be aware of which layer is some certain virtualization or certain networking functionalities are applicable in which layer, and we have to do it. So, if I have a cloud and I do not have networking, then a cloud is an isolated feature. We may have all the data, we may have all the machines, and we may have build a data center, but even if I have a data center and I do not connect the data center with the outside world, then the data center does not have any viability. It is like this, that if I have a railway train and it is not connected to a platform, then this is a server. If train is considered to be a server, then the passengers are the data packets, but they are only completely blocked inside this railway. Now, when the rail comes to a platform, some packets come in, some people go out, just like a networking, then it becomes useful. So, platform will be our network connectivity, which allows us to drop some packets and bring some new packets into the networking and go to the next station. So, next platform. So, without a platform, exactly how a railway train is not useful, similarly without networking, computer as such is not useful. Definitely a cloud cannot work without networking. So, the kind of networks in cloud that we are going to look at, we will see network in cloud and we will see cloud network. Cloud network further will be divided into cloud based networking, cloud enabled networking and network as a service. What is a network in cloud? A network in cloud is the implementing a cloud using the normal network. We are in this environment, we are using an existing network to implement a cloud data center. So, this is the conventional network to establish a cloud environment. So, therefore, there will be LANs and there will be internet, and we will connect our cloud components to specifically to a LAN, and it will have a general method of transporting the data packets over the internet to other data centers or to the client. So, this is the standard network mechanism. Now, network in cloud looks like this. If I have a server having all the components, the hardware, the hypervisor, the operating system and the applications, this is my virtual machine, and I have another server which also has all its components, and if I have clients, the service consumers, then these clients need to connect to these servers, and what helps are the network information card or NIC in each machine which is connected to the client's machine, and cloud environment can proceed. Now, this is not sufficient. Using standard networking for cloud is not sufficient. So much is dependence on the networking that we need to control some part of the network. We need to add some functionalities to the network so that we have a better environment to communicate with each other. So, that is what a cloud network does. This is enabling the network by including certain value added functionalities. Now, so the same servers will be there and the user will be there, but instead of using a normal network, now we have a advanced networking functionalities which will be added to the networking. So, these functionalities will be such as a VLAN, VPN or SDN that we are going to explain in the next two modules. But before that, let us look at what is a cloud based, cloud enabled and network as a service. So, a cloud based networking will be a virtualized network. The network will be virtualized, there will be a separation of the physical network from a logical network, and the logical network is what will be provided as provided to the users or will be used for cloud implementation. Here all the infrastructure and the services will be kept in the cloud, even the data for forwarding, switching, everything will be in the cloud. So, cloud will control the networking, and cloud will ensure that the networking is available for the others. In cloud enabled networking, the philosophy, the policies and the management of the networking will be with the cloud, but the data will be stored in a common shared environment where the forwarding and the switching data will be available. So, cloud does not control the complete virtualized networking environment. Cloud only controls, enables the virtualization of the networking in this particular way. Now, what is network as a service? When we provide a virtualized networking to others for them to use. So, this is managed networking service solution. delivered on demand and as a service. So, it works like this. Let us take an example. Say I am trying to implement a firewall. Now, if the mechanism of how to implement the firewall is not known to me as a client, then I can take a service of firewall implementation from someone else. Now, the way to do it is they can come and build the firewall in my premise, but the problem of doing that is in case something goes wrong in the firewall, again I have to call them to come and repair it. Rather than that, can I keep the firewall in the user's premise and I use a virtualized firewall, which means that I get the benefit of the firewall, but I do not maintain the firewall at all. So, how the firewall will be active? So, all packets that have to come into my machine will be rerouted to service provider's machine, and it will be filtered by the firewall constraints, and if it passes through, then only the packets will be delivered. So, network as a service behaves like this. All the networking solutions will be created as per the client's requirement. It will be created by the cloud service provider, and it will be provided as a service to the client. So, therefore, we get a ready-made networking solution without actually implementing the networking. So, as we said that any virtualization will require to touch all the 7 layers of the networking. So, enhancing all layers with the functionalities with value additions will be is the requirement. Now, there are two parts. One part is the affects the lower 3 layers, and this is called network virtualization, and the upper part which affects the 4 higher layers, and it is called network function virtualization. In today's class, we will look at the network virtualization part. So, first of all, the first entry point to a system for any networking is the network interface card or NIC. So, virtualizing NIC is the basic option for virtualizing a networking. So, virtualized implementation of a network interface card or hardware. The virtual NIC, the guest will not understand that it is a virtual NIC, but the physical NIC will not be made available to the guest. So, many things can be controlled using a virtual NIC rather than allowing a physical NIC. So, the virtual NIC will be connected to the physical NIC. This is how it will work. So, as a result of this, the virtual network will be completely private within the host and its virtual machines. So, this is how it works. So, here is our virtual environment where we have the guest operating system and we have a virtual NIC, and this virtual NIC connects to the actual hardware, actual NIC present in the hardware. So, how we do this connection? We do this connection using what is known as a virtual switch, or it is a software switch. This software switch allows to route all the requirements from the virtual NIC to the physical NIC. So, here is a better example of how the virtual switch works. Here are the VMs. The VMs have the guest. So, this is the one complete machine running 3 VMs in this example, and there is a virtualized, there is a hypervisor layer, a VMM layer as you can see, and the physical, this is the physical hardware part of the, underneath the VMM is the hardware part of the machine, and virtual switch resides in the VMM, and this virtual switch or software switch, so to say, will connect the virtual NIC to the physical NIC. So, it is a virtual version of the physical network switch, and the virtual network adapter is used to connect the physical network. It connects the VMs at layer 2. This is a layer 2 connection. Now, we use a software bridging to connect multiple virtual NICs to a physical NIC. This is the software bridging example, where we see that there are guest VMs, guest VM 1, 2 and 3, and each of these guest VMs have a virtual NIC. This is a virtual NIC, this is a virtual NIC, and this is a virtual NIC. Now, these virtual NICs using the virtual switch will have specific interfaces to which they have to connect. So, the guest VM is completely unaware of, just like we saw in our virtualization modules, that a guest VM, a guest OS in the guest VM or the applications in a VM is completely unaware of the fact that they are in a virtual environment. In a similar vein, here also the guest is not aware of the existence of this NIC to be the software NIC. They, just like a normal machine, non-virtualized environment normal machine, will expect the NIC to be there in its own hardware, and through the NIC it will push the data packets onto the network. Similarly, this VM will think, the guest OS in this VM will think that this is that physical NIC, and it will push through its data packets through the physical NIC, to the virtual NIC. The virtual NIC will take the packets, will use with the use of the help of the virtual switch, will push the packet to the physical NIC. This is the physical NIC of this server machine which are running 3 virtual machines, and this is physically connected to the outside networking physical link, and it will push the data. Now, what happens when the operating system or the base operating system wants to connect to the NIC? Even that can be done using the software switch. So, there is an interface for the operating system to connect to the virtual switch, and through the virtual switch to the physical NIC. So, this is called a software bridging, where it bridges the base operating system, the guest operating system of the virtual machines, using a software switch, using the virtual NICs and the physical NIC. So, this whole environment is called software bridging. Now, a very important part of having a hybrid is to use the physical environment as well as the software environment to create certain facilities. Virtual private network or VPN is one such mechanism. It provides secure encrypted connection to transmit data between entities running in different machines. So, what it does is, there is a physical network, but a virtual private network will provide an isolated private channels to between 2 entities that are residing on different parts of the system. So, what are the features? It is secure, because the overall bandwidth will be divided into smaller parts, and each will be dedicated. So, therefore, it is highly secure, it will be reliable, and it is scalable. How much bandwidth we want, that much bandwidth we can give to a specific between 2 specific. These connections, these private connections are called tunnels. So, we can build a tunnel between 2 entities over a physical network. A virtual tunnel is created, and using this tunnel, the packets between these 2 entities go in a secured manner. And this whole thing is it is possible to control this by the server through the software, and therefore, the whole network is a virtual network. So, VPN behaves more like a rail tracks, where if you see that these are all parallel rail tracks. So, therefore, if we consider this to be the bandwidth, then each track takes a train. So, this whole bandwidth can take perhaps 4 trains, and to ensure isolation, to ensure ensure security, we run a train in one track. We do not run opposite coming train in the same track. Now, these can be changed. The channel paths can be redirected using a controller. So, here is the example of the controller. When the controller is properly appropriately used, this network looks like this network, where the tunnels will be changed to other directions. So, why we are concerned about VPN in cloud? It's in the cloud network. The conventional network from the cloud network can be separated. Within this, we segment the resources or clusters, and VM to end user access is provided by through VPN. So, the resources or the clusters are segmented according to the VPNs, the special channels that are created across two nodes, and through these channels securely data can be provided. The next one is called VLAN. Now, what happens in a cloud is there will be many in a cluster there will be many physical machines, and all these will be connected on a LAN. So, the bandwidth of the LAN will be every machine in that LAN will be dependent on the bandwidth. So, if we consider a data center, then within the data center they are all on a LAN in a data center, and the complete bandwidth is available to all the machines, all the servers in the data center. The problem of this is that we cannot have different clusters, different groups for communication purpose. VLAN helps in that. So, it segments the LAN and it segments the traffic. The system within a LAN will communicate with each other as if they are in different LANs. So, it will segment some paths, and it will create communication paths among these groups in such a way that it will look like they are each of these groups, although physically they are on the same LAN, it will look like they are on independent isolated LANs, and they are connected over the networking. So, this way we get a improved performance, improved network performance, and also because of the isolation we can get an additional level of security. Very important in a cloud is the VLAN. So, therefore, how it is done? This is the router and this is the switch, and these are the different parts of VLAN. These are the different groups of computers on the original LAN, which are grouped in smaller isolated parts, and they are connected using VLAN. In a cloud environment, what is more important is to have this kind of isolation, so that the data center can be, in spite of being on the same LAN, it can be kept isolated. So, here is the overall example of how things are done in a server. So, these are the two switches, switch A and switch B. So, this is the server having the NIC cards, the NICs, and using the switch we can have the different VMs connected to different groups. So, whether they belong, the two VMs are belonging to the same server or not, they can be made to belong to different VLANs by using the VLAN segmenting mechanism. What is the difference between a VLAN and VPN? VPN is applicable on layer 1 to 3, whereas VLAN is applicable on layer 2, and VPN is a method of creating smaller sub network on top of an existing bigger network, as we saw that the channels are created using VPN, whereas in VLAN we group the systems which are not connected to the same switch and make them as if they belong to the same switch. So, therefore, VPN creates isolated channels across computers, whereas VLAN generates a isolation of computers within the same LAN. So, this brings us to the end of the first part of our networking, which is the network virtualization. In the next part, we will look at how the other 4 layers, the higher 4 layers can be virtualized using value additions, and this is called this will be called network function virtualization. So, to summarize our talk today, we looked at cloud networking, where first we saw the essentially basic standard networking and implement a cloud environment on top of that standard networking. That is what normally is expected to be done. And then we looked at how do we add additional functionalities to our networking to make the cloud a better environment, to make the environment better for the cloud communication. This includes virtualization. We saw that there are 3 parts where we can work. We can work on the hardware, we can apply the software, virtualized software, switches, routers and load balancers, and we have a hybrid of these two in VPN and VLAN. To make the VMs accessible, we have the virtualized NIC, which will be connected using a virtual switch, and the virtual switch will create a software bridge, and this software bridge will help the guest operating system, the virtual machines, the guest operating system and the base operating system to communicate with the outside world. So, we saw the VPN and VLAN. Now, in the next class, we will look at the next 4 parts, layers of virtualization, which we call the network virtualization. These are our references. Thank you.